Hello everyone, this is my third homework. The headline is to do simple digital calculations using Arduino and the keypad. First, let's see the program. This means in my Arduino sketch, I'm turning the Arduino IDE to look for the two fields named keypad pointer edge and liquid crystal dash I2C pointer edge, and include contents in my sketch libraries provide pre-written functions and definitions that I can use in my Arduino programs. This defines that we are using a 4 multiply 4 matrix keypad. It represents a 4 multiply 4 matrix keypad with specific characters assigned to each key position. These are used to define areas that specify the pin connections for the wheels and columns of a keypad matrix. This is creating an instance of the keypad class named myKeypad with the specified configuration. Keypad is the class from the keypad library. MyKeypad is the name given to the instance of the keypad class. MakeKeyMap. This function is used to create a key mapping based on the keys I will have a defined area. It takes the keys I will as input and prepares it for use by the keypad library to associate physical key prices with the characters. Row pins and clue pins. These areas specify the Arduino pins connected to the wheels and columns of the keypad matrix, respectively. They define the physical Y configuration of a keypad. Rows and clues. These contents specify the number of rows and columns in keypad matrix. They determine the dimensions of the keys area of how the keypad is structured. It helps in determining where to store the incoming characters from the keypad, in first none or in second none. If the first none state is true, we can use first none. If first none state is false, we can use the second none. The variable stores the characters of the first number being entered. It is of type string to allow constitution of multiple digits. This variable stores the characters of the second number being entered. Similar to first none, is a string to handle multiple digits. This variable stores the result of the arithmetical operation performed. It is of type float to handle decimal number. Ensure accurate representation of calculations. This variable stores the operator chosen for the arithmetical operation. It initializes with a space, indicating no operator has been chosen yet. These variables collectively allow you to implement a basic calculator. Like functionality where you can enter digits sequentially to form two numbers, choose an operator to perform an arithmetical operation, calculate the result based on the chosen operator and the two numbers entered. This initializes the LCD display. This clears the LCD screen, ensuring it starts with a clean display. This turns on the backlight of the LCD, making the text visible. Set the cursor to the first column of the first row of the LCD. Point the text Arduino starting from the current cursor position. Set the cursor to the first column of the second row of the LCD. Point the text calculator starting from the current cursor position. This pauses the execution of the schedule for 1 second. It provides time for the user to see the issue display message before proceeding. This clears the LCD screen again, preparing it for further operations. Set the cursor to the first column of the first row again. This is typically done to ensure that subsequent points start from the beginning of the LCD screen. This code means that is a conditional state that checking whether new key is a valued numerical digit. This section checks if a valued key is pressed on the keypad. Depending on first known state, it considers the pressed key to either first known or second known. It also prints the pressed key on the LCD display. This section checks if a valid operator is pressed on the keypad. If first known state is true, it sets the operator variable to the pressed key, indicating the operation to perform. It switches first known state to false, preparing to input the second number. Depending on the stored operator, it performs the corresponding arithmetical operation on first known and second known. It prints the result on the LCD display. This section handles the clear key press. It clears the LCD display, resets first known, second known result, and operator variables to their initial state. This function clears the LCD display and resets and calculator related variables to their initial state. It prints labels on the LCD to indicate where the numbers and the operator will be displayed. Second, we can see the collection type from the photo. According to the edited procedure, the actual mode is as follows: I2C module and LCD attached to the breadboard. Each row and clue of the keypad is connected to the digital pins of the microcontroller, from pin 2 to pin 9. Third, let's take a look at this simulation video. If we enter numbers and calculation symbols during the simulation, the LCD will display these numbers and calculate the results. Finally, let's look at the actual video. Also, if we enter numbers and calculations simple, the LCD will display these numbers and calculate the result. Thank you for watching. Please give some suggestions